Okay, we're back looking at the next section. Next section is operations with radical expressions. So radical expressions are with square roots. Now last time we looked at how to simplify them. In this section we're going to look at a few different operations. Okay, so the first one is adding and subtracting. So to add and subtract radical expressions, the radicands must be the same. Now the radicand is the number underneath the radical sign. Okay, and if those radicands are the same, you combine the like terms. So you think of them just like variables. Okay, so this first example, I've got 5 square roots of 2 plus 7 square roots of 2 minus 6 square roots of 2. This right here is your radicand, and they're all the same. So since they're all the same, I can add them all together. So what I'm going to do is going to take what kind of equates to the coefficients, same type of idea here. So I've got 5 plus 7 minus 6. And that gives you, well, 5 plus 7 is 12, minus 6 is 6. You've got 6 square roots of 2, and there's your final answer. Okay, so you combine what considered like terms. In this one, I've got a square root of 7 in those two spots. I've got a square root of 11 in those two spots. Those would be my like terms. So the first ones would be the square root of 7. I've got 10 minus 4. That's 6 square roots of 7. The second one would be a negative 5 plus 6. And that's essentially just 1, or just the square root of 11. And there's your final solution. Alright, so make sure those things are the same. If they are, you can add or subtract them. Now, if they're not, what we have to do is try and see if we can make them the same. So, for this first example, I've got 4 square roots of 54 plus 2 square roots of 24. Well, we saw in the last section that we can try and break those things down. So if I take 54 and turn that into 9 times 6, and I take 24 and turn that into 4 times 6, they can be simplified. So the 54, I can take the square root of 9 and get a 3. Now that 3 gets multiplied with this 4, and it turns into 12 square roots of 6. On the second part, I've got this square root of 4 times 6. The 4 turns into a 2, and it gets multiplied with that 2. So 2 times 2 is 4, square roots of 6. And now if you notice, my radicands are the same. They're both 6, and I can add these together. 12 plus 4 is 16 square roots of 6, and there's your final answer. Alright, so now knowing that, putting together what we saw just barely in the examples above, give B a try. Pause the video, come back in just a second. Okay, so for B, 12 would be broken down to 4 times 3. 48 could be broken down to 16 times 3. Okay, and what you guys should start notice, there's a common number in between these, and that's how we know they're going to work out. So the 4 becomes a 2. That 2 gets multiplied by this 4 down here, and I've got 8 square roots of 3. The 16 turns into a 4. That 4 gets multiplied with that 6, and that becomes a negative 24 square roots of 3. And 8 minus 24 is a negative 16 square roots of 3, and there's your final answer. Alright, so that is adding and subtracting, making sure your radicands are the same. If they're not, make them the same. Alright, next example is multiplication. How do we multiply these things together? Well, multiplication with radicals is very similar to multiplication of, anything with variables, real numbers, any parts of that. You can multiply what is similar. Okay, so in this first example, I've got this 3 and this 2. They're both on the outside. That means I can multiply them. So 3 times 2 gives you 6. Then I've got the 2 on the inside, the 6 on the inside. I can multiply those, and 6 times 2 is 12. Now, from what we saw before, I can break that 12 down to 4 times 3. And so the 4 becomes a 2. That 2 comes out and gets multiplied by the 6. 6 times 2 is 12. The 3 has to stay, and I end up with 12 square roots of 3. Now in the second example, we're going to use distribution. It's going to multiply there, and then multiply there. Okay, so 3 times 2 from the first two terms gives me 6. Square root of 5 times the square root of 5 gives me the square root of 25. We'll simplify that in just a minute. Okay, the next step, I've got the 3 and the 5 in the first and last, and that gives me 15. And then I've got a 5 and a 3. Multiply that, that gives me 15. Now we go to simplify. Well, here I have the square root of 25, which is just 5. And this is all being multiplied, so 6 times 5 is 30. In the second step, I've got the square root of 15. The square root of 15 can't be broken down, so it stays as the square root of 15. And so 30 plus 15 square roots of 15 is your final answer. So multiply just like you would a normal number. Alright, pause the video, give C a try, come back and try it out with me. Okay, so we go through and we distribute. So the first term through gives us 15 square roots of 6. Okay, so the 5 times 3 is the 15, 3 times 2 is 6. Multiply the next one through. Well, this is 5 times a negative 1 basically, so you got a negative 5. Square root of 3 times the square root of 3 is the square root of 9. And now these two things can be multiplied together. So the 15 square roots of 6 is done the way it is. This is a 3, so 5 times 3 is 15. And there is your final answer. Alright, so that's how you multiply. Final thing that you want to be able to do is kind of take this and apply it. So let's just say we're building a planter. And we want to know what's the area of this planter. And the planter is the shape of a rectangle. We've got the length, we've got the width, and we got to go to area. Well, area is multiplication. We take our length, and we take our width, and we multiply them. So I've got the square root of 5 plus 4 square roots of 3. And I want to multiply that to 5 square roots of 2 minus the square root of 3. Well, I've seen binomials before, and so have you. And all we're going to do here is FOIL. So first times first. Well, that's 5 times the square root of 10, because you've got the 5 times the 2 on the inside. Then you take outer. So that's the square root of 5 times the square root of 3, which is a negative, and it gives you a negative square root of 15. Okay, then we go inner. Well, here's our inner. We've got 4 times 5, which is 20. 3 times 2, which gives me the square root of 6 underneath. And then last, I've got 4 times a negative 1, which is negative 4. Square root of 3 times the square root of 3, which is the square root of 9. So that's been FOILed, and now we look for common terms. Well, if you look, we've got a 10, a 15, a 6, and a 9. The only thing that can be simplified here is that 9, which turns into a 3, and then the 4 and the 3 get multiplied. And the 10, the 15, 6 cannot be broken down, so I've got 5 square roots of 10 minus the square root of 15 plus 20 square roots of 6. Over here, the 4 times the 3 gives me minus 12, and there's your final answer. Now, while that doesn't seem to be something you can use in real life, it is doable, okay, if those were your measurements, and you've got our answer. Alright, hopefully this helped you see how to simplify some of these things. Okay, multiply, add, subtract, just like you would normal numbers, as long as they are considered quote-unquote like terms. Alright, if you need help, let me know. Otherwise, good luck on your assignment.